Today we will be drawing lines of fit, okay? So this first one says the table shows the number of hours of sleep before a test and the percent totals on that test for a group of students. Construct a scatter plot, then draw and assess the line that seems to represent the data. Okay, so I went ahead and labeled these. There were 10 spots, so I did one for each hour of sleep. And then since there were 10 spots vertically and I noticed none of my numbers went above 100, I knew I could count by tens. Okay, so I'm going to go ahead and plot these. We have 9 hours of sleep with a 98%. Okay, 4 hours of sleep with a 20%. 6 hours of sleep with a 72%, just above that 70 there. And then 5 hours of sleep with 33. 8 hours of sleep with 88, and 9 hours of sleep with an 87. Okay, so you can see here that this has a linear relationship. And if I draw this line here, I have about an equal number of dots that are above it, 1, 2, 3, and below it, 1, 2, 3. Okay, so I drew a line that kind of went through the center of the data. All right, and when we get into writing equations for these lines, you may want to pick a line that has a slope that you can easily get. Okay, for instance, here, okay, I have a 3/2 slope, 3/2, see that? And it is very similar. I have 2 that land on and 3 that are slightly above, but it's still very similar to that same line, okay? But that line goes through the data, a good estimate of that. Okay, let's take a look at one more. Okay, the table shows the age and weight of babies under a year of age. All right, so months and their weights. So 5 and 16 pounds. 5 months, 16 pounds. 9 months and 17 pounds. 2 months and 12 pounds. 6 months and 16 pounds. 4 months and 14 pounds. 3 months and 13 pounds. And 8 months and 18 pounds. Okay, again, a close to a linear relationship, positive. All right, again, I want to make a line that goes through most of my data here with the same number above and below. And you can also see that this created a slope that is easily figured out. Okay, but most importantly, I have 2 below, 2 above, and 3 on the line. Okay. So that is definitely a line of best fit, a line that best fits the data. Okay, there's one here that you can try on your own, as well as 2 more if you would like. Then we're going to take a look at these down here that already have the lines plotted for us. So it says the scatter plot shows the age of a chicken and the average number of eggs laid annually. Okay, so their age and the number of eggs. Use the line of fit to make a conjecture or an estimate about the age of a chicken that lays 230 eggs. So they've got the scatter plot, they've got the line of best fit. So I'm going to say, okay, for 230 eggs, that's about here. If I follow this over, it's going to hit my line right about 1 year old. Okay, so I would say a chicken laying 238 eggs is about 1 year old. Okay. Number 8 says the scatter plot shows the amount of snowfall and average time to commute to work while traveling on Route 422. Use the line of fit to make a conjecture about the time it takes to commute to work when the snowfall is 6 inches. Okay, well, this is our scatter plot in our line. So I go to snow at 6 inches. I come up, figure out where that would hit my line. And I would say it would be about 64 minutes, maybe 63, 64 minutes. About 63 minutes. Okay, it's between 60 and 70. It's on the lower side, not quite halfway through, I would say. So 63, 64 minutes would be good estimate there. Okay, you can try 9 and 10 on your own there.